Okay, start another recording. All right. Okay. So I am planning this to actually, address in, an individual basis and during the workshop session, which I offered tonight. If you'd like to stay after class and work on anything, you're perfectly welcome. What I plan to do right now is to go to this homework and open it and go through this assignment. Okay, we discussed this as the format that was discussed was that it may be very useful to have an object which acts as a stack of integers. So then we can create brand new file, make it a header file, and start working on this inStack class. So the inStack class should work like this. Should work like this. An object is instantiated, right? So again, brand new 3D. Now I purposely will draw it like, a tall object because it may contain a lot of elements in it. And when someone says push, the element, we're going to store integers. The elements are going to be stored inside. Another push, and the numbers can be stored like 2, 5, right? A little bit like playing a lottery, right? So we're trying to create a useful concept which works as a container. When someone says pop, we're going to use this format to say, well, let's return the value from the stack. And when we return the value from our stack, we will give the user back this value. However, at all times, we will maintain our own little stack pointer, SP, right? And little integer here, little 3D box, which is an integer, which basically constantly points to the top of the stack. So if someone says pop to remove an element and obtain the value, possibly, right? The result of it is that the stack pointer has to be adjusted to the previous element. And when someone says pop again, the stack pointer again gets adjusted. And when they say pop the value back again from the container, this stack gets yet again adjusted to a non-existing element if they, basically pointing to a non-existing element or something like that. If they try to pop again, the program is allowed to completely crash because it's the user responsibility to watch out and not try to extract anything from an empty stack. However, they can do push again. And in case of a push, let me perhaps, try to erase some of this if I manage to do that. All right, so if I erase some of these drawings here, right? So, in case of a push, so somebody does this to our stack, stores this value. So this is brand new value 2. This is garbage. I don't know what this is. It may be still sitting in memory, but no way it's accessible. So the stack pointer moves from this location. Well, it just logically stores like 0 or something. So it moves to the next location. It basically gets adjusted and gets moved to the next location. If we push more data into the stack pointer again keeps pointing to the next available element or something like that. If we keep pushing more and more and more, eventually we exhaust the capacity here, right? So brand new element is pushed here, another value is pushed, and finally stack pointer will basically point to maybe a location that is no longer a legal location, so that we say at this point the user of the stack must recognize that the stack is full and can no longer be pushed any values into it anymore. So you can only pop. Once you pop, then you can go back and push more. So that's the rules of the game. So this is the type of container that we're trying to design. In my view, let's go back to our project. I will say close all documents, and even more so say close solution. On the website I posted previously, I did some of the work in class, and I did some demo here. I did some examples, and some of it will be replicated today, but this is for you to read, right? I'm not going to follow this or read this. You can read it on your own. So instead, I will just do some of this experimentation, and then just try to push you on the right path to solve this homework. So given this design idea right here, right? So I need to design this object. I need to make it usable. Let me just say new project. I guess I'll switch back to console application, right? So new project, console application. I will put it, how about I save it on my F drive as well, my portable drive this time. Okay, and I will name it int stack demo. Okay. So again, we'll make it no precompile headers, empty project, finish. So and let's start with the main function. I wonder if the homework handout already includes, let me just resize it so I can read it. It says do this and that. Okay, I will just quickly put together a main function. It doesn't seem to be part of the handout. So create this main program, right? A new item, create the main program. Add that. Okay, so the idea is this: somehow include the file named I don't know, int stack.h, which we're supposed to write. The stack doesn't exist just yet. We're trying to invent it. And then say, okay, if we have this int stack object instantiated stack, right? Then we can say, okay, if we did that, then we can say push, right? So we can push some values in there, like 555, right? Then maybe push 777 or whatever. You know, it's designed to store integers. And as we do this, it will store the values in our container, right? So this will happen. And then I can say std cout if I include everything. Then I can say stack pop, and it will display the value stored, right? And then I can do it 2 times in a row, and it should be able to display everything. So include IO stream, right? Okay, so something like that. Going to my project location in stack demo, I can just say, all right, I want a new header, which is just another text document, right? So int stack, what I named it there, int stack.h. Okay, so here it is. rename instack.h, and quickly open it. And of course I need the header guards, right? If and I typically, what you can do here is right click and say copy full path, and you can just like do this, just get your path, and then copy the name of your file. Oops. Copy the name of your file and use it here. So I typically use suffix like included when creating header guards, and then I typically double click, Shift Control U will make everything uppercase, or you can do it through the edit, and pretty much all editors do that for you. And then we say, okay, if it's not being defined just yet, then define it, right? Define, and the preprocessor symbol gets defined by 0 assigned to it. And the proper syntax requires if and def to have and if. And here we just use this as a comment because it's not required by syntax. All right, so here we go. So inside here we say class. In fact, why do I have to invent things if this handout tells me this is what you should do, right? You should have your instack, right? And so that's what I should have. I should just do this, right? So these are some samples, sample functions here that we need to implement. Of course, to be able to implement, we can say add a new item and just name it instack. Instack.cpp. All right, C++ file, add. All right, so it's a blank file. You can now close the solution and work side by side, as I always like. And it's always the same thing. Well, first of all, this is our public interface, so it needs to have public, right? And also, I would say, well, I'll add maybe a constructor to it as well to make it more useful. All right, but for now, quickly copy and paste into the implementation file. All right, so we get all this. And then, of course, it's part of instack. This is just the syntax that we have to use on each of these functions. We need to define them. They all have to have the body, and I will do it in a second. And one of the very useful features, which I probably couldn't have survived without, if you press Control A, selects everything, and then you can go Edit, Advanced, Format Selection, so which gives you like default formatting options, or you can press Control K, Control F, which I normally do. But this basically formats everything, so you don't have to struggle with those individual pieces. All right, it's time for me to save this.